Sorry for the delay. I always say if I don't get to lecture like an hour early to prep, it doesn't come together, which is true as usual. So I have the Tollens reagents halfway on the cart and then I ran out of time. So I'll have to finish getting it. So we might have to save that demo for while y'all are doing the quiz. And my other thought was I was going to do this other demo. If I can pull up the demo, I can show you what I was going to try to do. So the classic test for alcohols is this reaction, and so it involves potassium dichromate in a sulfuric acid solution, and then it would change to green. It should go faster with the primary, slower with the secondary, and then no reaction with the tertiary, except, so I'll give you an insight to how EH&S generally works. And now I remember this conversation. It's like, oh, what is this potassium dichromate for? Oh, I don't remember. We don't use it in our labs. And for some reason, like, people don't like chemicals chilling. I don't know why. Like, people don't understand expiration dates, and especially if we're talking about inorganic salts that aren't doing anything, like, they're going to last forever. You know, it's weird. Like, the sodium sulfide reagent, that was an exception. Like, usually in Gen Chem, these things will sit as powders forever. But they were like, no, let's get rid of it. It's chromate, heavy metal, so it's gone. So now we can't do this test. So I was trying to scramble to like get something else, but yeah, I'm not sure. Like I said, kind of ran out of time there. So yeah, I apologize for that. And that's why y'all should be chemically literate, so that you're not scared of like powder chemicals sitting in the closet. And then that's why I always have to like fight for chemicals. But anyways, it's impossible for me as a chemist too to like remember every possible reaction I want to do with a chemical. But anyway, so we will try to do the Tollens at the end of class. All right, so we'll just quick announcements. Oh, I forgot. So I'll hand out the midterm or final. I forgot to print it out again. I didn't get here super early, and that means I didn't do anything apparently. And then, so rest of ice cream lab today. And then, like I said, tomorrow, if you want poster help, I will be around. So Earth Club has a meeting at 11 a.m. So I'll be in like HEC 314, so not our usual lab, but the middle lab. And then let me know if you're coming though, so I know to expect you, or if you want to meet earlier or later. Again, just let me know so we can figure out a time, or again, so I know how long to hang out for. And then my plan for next Tuesday is again more poster session help or paper. But again, just email me to let me know so I know to expect you. And like I said, so I'll get the finals printed, hand them out in class today. And I think I said final paper. So the final exam, ideally due by June 6th, so that would be next Friday. And then 5 p.m. mailbox. And then the essays we can take by email or electronically, like I said. Maybe I'll set it up on Blackboard. And that would be up until, sorry, I gotta look at the calendar again, what the next Friday is. So June 13th. And most people's papers look good from last quarter, just some reworking. So if you want more help with that, again, happy to meet. Friday, Tuesdays are good times. We can, of course, make other arrangements if those dates and times don't work.
What's the mailbox for the exam?
Oh, that's on the 3rd floor. So that would be, I just said 5 p.m., 3rd floor mailbox, and then, you know, that's when the office. Yeah, in the office hallway. And then, yeah, we're still doing our poster presentations, correct, on Thursday. Our poster presentation party.
So next Thursday?
Yeah, so next Thursday is our final poster presentation. And like I said, it'll be like a symposium style. We'll probably break off into like 3 groups for the class, so do like 3 sessions. So roughly like 6 people-ish present, and then, you know, rotate around, kind of casual setting, and then switch off who's presenting. Is that any other questions for end of the year, what we're doing? All right, let's finish up our chapter here. And so now we're looking at our functional group carboxylic acids. And so this is primarily what gives, right, organic compounds their acidity or makes it acidic. So we've seen acetic acid here, otherwise formerly known as ethanoic acid. So we'll look at the naming system. And like we mentioned, so we had an aldehyde, and we could form this from our primary alcohol. So then our primary alcohol gets oxidized to make an aldehyde, and then it can undergo a second oxidation, which again, there's probably a test for this where you can distinguish between the primary and secondary alcohols and seeing which one actually undergoes a second oxidation. And again, the aldehyde forms the carboxylic acid there. And so I was kind of looking up something like this demo, but like I said, I kind of ran out of time to figure out the proper conditions, because I think there's ways to test as well between the alcohols using permanganate, but I'd have to see what proper conditions. Probably acidified here, so here's again our aldehyde, and so using permanganate now as our oxidizing agent in acidic conditions. Again, we make our carboxylic acid there. And then again, just appreciating kind of what happens. So we keep this part, and then we're just losing, right, our H here, and it gets oxidized. So we're not looking at our mechanism though. And so here's our dichromate reagent that now I'm really sad that we threw away. And so this scheme, again, just reminds us how we got to the carboxylic acid and the two oxidation steps. And so again, our strong oxidant reagent made the aldehyde, right? We had to lose a hydrogen to form our aldehyde here, making our double bond, and then again, second oxidation to make the carboxylic acid. And we can write a reminder, right, that a secondary alcohol makes the ketone. So just, again, I know we have a take-home final, so you don't have to memorize groups right now, but it will come for OCHEM, where you'll have to distinguish between aldehydes, ketones, and reactivities. So again, just thinking about those differences. Okay, the ketone is going to have carbons on the center, no hydrogens, so it can't do another oxidation. And so I think we've seen this in our acid-base chemistry. So again, this is just a reminder of this. And so we've kind of discussed this. We can look at it again though. Again, the mechanism, so this is a good refresher. So okay, we said we have this carboxylic acid group, and then of course it has this equilibrium in solution. So we're going to see how it reacts with water. And again, we know that this is acidic. And so water is going to act as a base and then deprotonate it. And so again, that's where we get our now carboxylate ion. Draw out our electrons. And then of course, just recall that we can draw the resonance form. So moving these electrons down, these go up to form our resonance form, and again our charge is just spread across. And if you remember, sometimes this is also represented something like this Again, kind of showing how it's delocalized across. All right, so then going into naming. So again, we're going to identify our longest chain, and then we'll replace it with anoic acid. And then by definition, right, our carboxylic acid has to lie at the end of a carbon chain, so it's usually given in the 1 position, and then again, not included. So these are pretty straightforward. So we have 1, 2, 3 carbons, so prop for 3, so propane becomes propanoic acid. And then now we have, so let's name this one, right? Find our primary chain. This has to be 1, and then 2, 3 as follows. So identify our groups. So we have a chloro group, so 2-chloro-propanoic acid. Straightforward. And then this one, so again, same thing, right? Identify our longest chain. So in either way, 1, 2, 3, 4, or 1, 2, 3, 4. And then we have a methyl group, so 1, 2, 3, because again, right, this carbon has to take the primary position. So 3-methyl bute for 4, so butanoic acid. And then again, same thing, 1, 2, 3. So there's our prop, and now we have 3 chloro groups on there. And so 2 on the 2 position, so 1, 2, and then 1 on the 3. So that's how we get this 2, 2, 3. So again, telling us where the chloros are. And then trichloro, so we know that there are, again, 3 chloro groups at those positions. All right, so then we'll practice naming with alkenes. So if we have an alkene in there, then we need to indicate where our double bond is. So again, pretty similar naming system, what we've been doing. So 1, 2, 3, 4, 5, and I should have labeled them. So we know it's pentane, right? So 5, but then pentene, because we have a double bond. We have to identify where the double bond starts. So at the 3 position, again, relative to our 1 here for our carboxylic acid. And then notice how we also indicate how the groups are relative to the double bond. So right opposite sides. So then it's called trans 3 pentenoic, and watch that little E there, pentenoic acid. And so again, let's just kind of go through that exercise. So find our longest chain, 1, 2, 3, 4. So okay, that's our longest chain. Let me highlight that. 1, 2, 3, 4. And then again, now we're looking at our groups relative to our double bond. So now we have E for being on the same side. So E2 methyl, again indicating our position of our methyl. And then 2, since it's also where the double bond starts. So 2-butene for our 4, butanoic acid. Questions on those? So let's look at a few other kind of like groups and a little difference in naming. So now let's say we have this sort of situation. So here, right, we have a cyclopentane as kind of our longest carbon chain, and then we're attaching, right, a carboxylic acid group to it is kind of the difference in how to think about it. And so then this one would be called cyclopentane carboxylic acid. So this is, again, something you could see where you just add the carboxylic acid. And then let's look at this one. So kind of following this one, what might you name it? And see if you can guess what you need to indicate. So I am showing stereochemistry here. So what are we showing? Let's see if you can try to come up with a name. So what might we guess for a name? We can kind of put the pieces together too. And so keeping things in mind, right, we're going to assign this. So this is attached to carbon 1 for priority, right, 2, 3, 4, 5, 6. And then we don't need to say where the carboxylic acid is, but probably need to describe the bromo in relationship. Any ideas?
Maybe 2-bromocyclohexane carboxylic acid.
I like it. So 2-bromo. And then we're just missing one little part to it, having to do with the stereochemistry. So we just might need to add a word in front of it. And so what does this look like to you? They're both kind of going up. So maybe the same side. And so when they're both up like this, then we can call this the cis isomer. So then more correctly, it's cis-2-bromocyclohexane carboxylic acid. And just to, again, compare, so this is just another form of stereochemistry where you have this 3D up-downness. Again, you'll be looking at plenty of chairs in OChem and cyclohexane. And so now this would be opposite, right? One going up, one going down. And so this would be the trans 2-bromocyclohexane carboxylic acid. Again, we won't get too wound up on the stereochemistry in this class, but this is a preview of what's to come in OChem. Just let people copy these structures. They also sell like hexagonal paper and stuff that some people like for OChem. If you're planning ahead and like neat notes. And then so let's try another one. So you can maybe guess one of the names and then I'll tell you its other common name. So guesses for the name. What's this ring called? Don't overthink it.
Benzene.
Yeah, so then it's benzene carboxylic acid. And then this one does have a common name that I'm pretty familiar with. So people mainly call it benzoic acid. Again, not to confuse you. We'll get a few more, so I'll draw this one out. So see if you can come up with one of its names, and I'll tell you the common name. Actually, several common names. You might recognize this one. Anybody want to try to guess a name? How are these similar? How are they different? What do we add? What's this group called? Hydroxy. And so then, right, we could tack it on to this one. Again, we just need to describe its relationship. So this has to be 1, so that makes it 2. And then we get, so it should be 2 hydroxy, and then we could say benzene carboxylic acid or benzoic acid. No one recognized this little guy though? So this was our salicylic acid friend. So also known as salicylic acid, and then it also has another name, so phenolic acid for our phenyl group. So 2 phenolic, describing that relationship. Again, as if there aren't enough names. All right, let's see if you can figure out this one. If I can draw it. Any guesses for this one? What's our longest chain? How many carbons?
5.
So 5. So I'm just going to, again, build our pieces, right? So we have pentanoic acid, at least. And then, excellent. I see it in the chat. So, right, that means that we have a hydroxy on the 3 position. So 1, 2, 3. So that's the only little missing part we need to add is 3 hydroxy pentanoic acid. Excellent. All right, let's try, this is a weird one. And so let's see if we can make a guess. And see if you can remember what special name this took when there were other groups and stuff in there. So now we have again, a carboxylic acid group dominating. So do you remember what this one became? So how many carbons in this chain? So I see 4. And then did we remember what this might be called? I took a short name. So these become oxos. So that is kind of weird. So this is 4-oxo and then butanoic acid. And so now I'll just draw out another permutation of it. Again, just so we can appreciate that in this case, even if it's at the middle or the end, it's an oxo. So sorry, 1, 2, 3, 4. Oh. So how many carbons were in this one down here? 5. So 1, 2, 3, 4, 5. And then what position Is our oxo group in then? I think I heard it. What'd you say? It's 2, yeah, second. So 2 oxo, and then 5, so pentanoic acid. Not too bad. All right, let's try, see if we remember what this group is called. So what was that? And then I believe the notes should be live and syncing, but okay, yeah, I was gonna say just double check, let me know. Everything's been a little wonky since I switched computers and stuff, but I think it's going now. And so I think we might have forgotten the name. All right, that was weird. So this is an amine group or amino when it's in our name. So how many carbons are in here? What position is our amine group on? Oh, recount. It should be 1, 2. Yeah, it's always good to label your carbons, honestly, right? Like, again, that's my biggest hint for OChem is like write them, number them. Counting is so important. So then we should have 3 amino propanoic acid. So count, count, and recount. Let's look at a few other kind of weird ones. So what happens if you have 2 carboxylic acids in our group? So we can go through this one together. So of course, okay, 2 carboxylic acids. Let's see how many carbons are in our longest chain. So 1, 2, 3. So okay, propane. So now we can say propane di for 2 of them, so dioic acid. And then I'll start drawing a similar one. Again, just so you can see. So what if we had 1, 2, 3, 4. Sorry, just making sure I got my carbon count. So 1, 2, 3, 4. And so again, just to compare, now this would be butane dioic acid, again for those 2 carboxylic acid groups. then let's try one. We'll do one challenge one. Let's see if we can name. So this one could be tricky. So of course we want to give the carboxylic acid our first priority, but then the question is, do we go 1, 2, 3, 4, 5, 6, or should we go 1, 2, 3, 4, 5, 6? So in comparing those numberings, right, we're just trying to make sure that these groups get the highest numbers. And so if we use the blue numbering, right, we would get 3 and 6. So that's not as ideal compared to 2 and 5, right? So 2 and 5 are both lower, so that's better for assigning higher priority. So that's why you select that numbering method. So 1, 2, 3, 4, 5, 6, so the orange ones. And so now, did we come up with a name? You had to remember what this was called too, so this is a nitro group if you didn't remember. So nitro groups as well tend to be pretty colored. Any guesses for a name or pieces of a name?
2-chloro, 5-nitro, 6. I was looking up what 6 is from the CHEM is called.
Or oh, but what's the basic ring called? Or
oh, benzene.
yeah, or so we could either call it benzene carboxylic acid, or we could abbreviate it to benzoic acid. So I'll put or benzene carboxylic acid. Excellent. So any one of those kind of variations. So again, right, you could have said benzoic acid or benzene carboxylic acid, and then have your 2-chloro-5-nitro there. Questions on those naming? All right, so now we're going to look at some reactions. So like we had kind of briefly mentioned previously, some of these acids and even alcohols potentially could be reacted with sodium or with a base here. So we have, so first this is shown obviously our neutralization reaction. So we know that. So just kind of going through our reactions. And then these, so they could also be formed from the addition of like sodium or potassium metal. So going back, where do we have it? no, I can't find where I wrote the alcohols. But basically where we can deprotonate it. So let me just, you could take, let's just say, ethanol and react it with sodium metal to again deprotonate it and make this compound. So this could also be a test for alcohols. The reason why I'm not doing it is because alcohols tend to be wet anyways, so it's difficult to determine whether you're really reacting the sodium with the alcohol or with whether it's reacting with water in the alcohol. So it's kind of confounding and not the greatest test. All right, so then what we want to look into as we finish up this chapter are condensation reactions. So that's what we should label this section. So condensation. And so a condensation reaction is where we lose water. And so now we're kind of getting into our synthesis of esters as well, or other polymers. So I think next week we'll take a closer look at polymers. But looking at this one, so terephthalic acid here. So this would make a good, so this would only be used for one part of our polymer. And so a lot of these polymerization reactions, they either occur by two different mechanisms. So now this is a slight aside. And so either they go by some sort of radical mechanism. So that's usually how like ethylene is formed, is some sort of radical induced mechanism. Or they go by this condensation mechanism. And so this is a good one because you can tell, right, it can react on both sides, which obviously you want if you're going to make a polymer that chains. And then typically you react this with some sort of amine, and again it'd have to be, right, like a diamine, and who knows what the heck's in there. So obviously our group for whatever, right, ethylene diamine is commonly used. I mean, there's like a bazillion amines. And then we'll lose water, so a hydrogen here and this OH from here, and they'll end up making a carbon-nitrogen bond. So that's what we'll be looking at as well. And so let's also look at the mechanism for our ester synthesis. So I think I briefly talked about that when we were looking at some of those alcohol naming, that they were strange. And a lot of these namings go back to the esters. And so esters are formed from an alcohol and a carboxylic acid. And so we do this condensation reaction where you lose our hydrogen from this one, our OH on our carboxylic acid, and then make a new bond. So new bond of this O, right, to this carbon here. And so then, again, we have our namings from our ketones. So again, naming it, so we have our ethyl methanoate, or rum. And so again, this is where all the flavorings come from. So here's pentyl. And so, right, we can see where it came from. So pentanol here for the alcohol group that's attached. And then, right, just ethanoate, or acetic acid, I should say, right, from 2 carbons. And so this is the banana ester that I mentioned. So again, right, that very distinct kind of Laffy Taffy. Oranges has an 8, 1. So apples, so methyl butanoate or methyl butyrate from our 2 sides. So ethyl butanoate, so again 2 for our ethyl, and then butanoate for our 4 here, and that's pineapple, and then pentyl butanoate, so pentane, butane again is apricots, and again they have all these other common names. So these are fun. This is a nice easy lab to do. If we had kind of better, if we had a rotavap or a better way to like evaporate solvent, these would be fun synthesis projects. And so now we're looking, again, pretty similar reactions with fats and oils, and then we can also break these bonds. So when we add things together, so again, now we're adding, so you can see a theme here, so adding an alcohol and now another carboxylic acid. So adding these two is again another condensation reaction. And we form water as our byproduct, and then of course make our bond here. So this is kind of how to make soaps as well, so it forms this bond. And then if you want to hydrolyze it, so hydrolysis now implies, right, that we're going to add back in H2O. So it's the opposite of our condensation reaction. And then we're also going to break our bond then. So right, we're doing the opposite. So now we're going to break our bond and add water back in across. And so looking at this mechanism, right, it's just a reverse reaction. So now we add water here. And so then we can reform, right, our alcohols. So now we're breaking all our bonds and then reforming our carboxylic acids as well. So there's our carboxylic acid. All right, so I think that's about it for lecture. So I left the quizzes with the demo too. So I'm going to run and grab probably the quizzes first, hand those out, and like I said, I still need to grab a few test tubes. But once I get it set up, which shouldn't take me too long, then I'll probably just interrupt y'all real quick so you can see the silver mirror test. So like I said, let me run and get those quizzes, and then feel free to take your break and stuff. It'll probably take me, 10 minutes anyways to run around and get the stuff. I'm going to leave the stream going so y'all don't miss the Collins test. So yeah, let me grab the quizzes. And I need to print out your final.
I don't know, because like they're like the rubric is yeah, and then for my paper, because I like only have I just like I don't know. I'm just gonna blab about it's just kind of like it used to be.
Did you see your video?
No.
Wait, did you actually do it?
Oh no!
That's epic!
Dude, I went home and I was like, Dad, I think I was cringe today.
The one time I'm not online, bro.
I was like, Dad, I was the cringe
Wait.
science kid. He's like, scientist, how cool.
Wait, listen,
Isn't it? But like, oh no.
We're gonna watch it. We're gonna watch it. We're gonna watch it.
No! Oh my god. Y'all prepare for some heavy levels of cringe, I'm sorry.
Girl, I'm not showing everybody. I'm not walking around.
Did you guys look at
This is for me.
Oh god, did you guys know what you're I'm right now, I just realized.
Wait, when did you go?
No!
I thought you would put like music over it.
That's horrible. I didn't expect you to actually do
That is so freaking funny.
Who's good? Is that me?
The A?
Yeah, that's me.
That's me. That's why I was like, I should put music over it. That's epic.
I will forever be. Wait, how much did she get? Oh my god. Oh my god.
Ew, I need to shut up. You're so obnoxious.
Girl, you're fine. I can't believe that.
That is so freaking funny.
So everyone on
Oh my
screen.
gosh, yeah.
Oh my god. Wait, what is wrong with it?
It was red. But they saw it. I don't know. Maybe it's someone you know in this class who showed me. It was so freaking funny. Oh.
Oh, we're just talking.
All right, I think I'm going to interrupt y'all now. Hopefully I'm ready. So I'll walk you through how to make this solution. So this Tollens reaction has to be prepared fresh, first of all. So first all I did was dissolve some dextrose in water, since that will give us a positive result. And so now I'm just going to add some silver nitrate to our test tube. And then we have to prepare what's kind of called Tollens solution. So that's what we're doing initially. But like I said, we can't prepare it and store it. It has an explosion hazard. So okay, all we've done is put some silver nitrate in there. And so now we're going to add some ammonia until we get a brown precipitate. So we have a precipitate, and then we want to keep going until it redissolves. Okay, perfect. So now we have a clear solution again, so we've pushed it to an ammonium complex. So I think this is the 2-coordinate ammonium species. So right, we took it past, because probably we formed silver hydroxide probably initially, right, when we added the ammonium hydroxide or ammonia. And then we kept pushing it until it formed, like I said, the dicoordinate ammonium species to silver. And so now we'll add some base to it. It may go now it's kind of brownish, and so now I'm going to add a little bit more ammonium too, just to keep it dissolved. Just clearing it up again, so now it's clear. And so now this is our Tollens reagent, and so now we're going to add our glucose to it. And kind of shake this around a little bit. And so you can see it's kind of turning brown, so that's a good sign. So keep shaking. And so it should start depositing our nice mirror film on there. So this is looking promising. I can start to see, you can see it in the camera, right, that little sheen forming. So this is looking nice. You can see the nice mirror coating there. So I'm just going to keep shaking it for a little bit. I'll probably kind of pass it around quickly. So I don't want to have it hanging around too much right now. So it does form an explosion hazard of fulmaric acid. So I might actually go dump this. So what I'm going to do is dump this solution, and then I'll come back and let you look at the mirror a little better. So again, you can see that nicely in the camera, and it's forming a nice mirror surface. So again, I'll let you all see this in class, but let me go dump this. So the proper disposal procedure is to just flush it down, our remnants down the drain, again, so it doesn't form any explosive solutions. We don't want to keep this. so now it's back. So like I said, I'll pass it around. Again, I'm just showing it off for the camera again. So now we have silver plated onto there. And then for proper disposal, you would have to get it off with nitric acid. So hopefully Daphne's paying attention since you might have to do this later. No, I'm just messing with you. But yeah, so now to properly clean it, you would just add nitric acid to redissolve it and then flush it down the drain. So yeah, I'll hand this around. I don't know if we want the test tube rag, just in case you want to hold it. It's cool there. And then, like I said, I'm going to go run and print your final since I forgot to do that. Yeah, just pass it around. So, like I said, that's how they used to make mirrors. I really don't know how they do it now. If they still use the same technique. But pretty nice.
I have like all of them that include up, and it's just like 2 pages of each of them. You know, Kristen, and that's just like, it's fine. Oh, okay, I was like, I can see. Well, I think she's gonna end up take some exam. That's why I'm waiting.
See, you see. It's not actually working because I got ABC.
it's so cold. Because I went in earlier and I was like, dude, it's so cold. Yeah, well, this one's really fast. I guess apparently, social, it's like 2 weeks with this one too. Yeah, they sent them the mail for her. So she was like, she needed to do it to 14.
And so I'll hand out the exam for take home. Probably the only thing to really note is that I would like a short explanation even for the multiple choice. It doesn't have to be elaborate, but just kind of show some work or whatever, so I know you're not just, you know, cheating off the chat GPT or each other. And again, take home. And so kind of the idea is you can, don't ask each other for like specific help on how to do a question, but right, you could ask each other general concepts. If you're really stuck on a question, you know, just ask me for help as well. Obviously, we still have a little bit of the polymer chapter to cover that's on your exam. So if you get stuck with that, right, ask me for help there.